My name is Dr. Jana Houser. I'm an atmospheric scientist in the Department of Geography here at The Ohio State University. My expertise is in tornadoes and the supercell thunderstorms that form them. So recently there was a pretty big blockbuster hit called Twisters that hit the theaters this past summer. And in that movie, there's a character named Javi who is working to deploy a network of 3 phased array radars in very close proximity to the tornado. And the idea behind this is that if you get 3 radars that basically are triangularly located around the tornado, then you can detect a 3-dimensional wind field within the tornado. This is actually a real scientific concept, and I have personally worked with this type of technology and with this type of methodology since my graduate student years. The idea is that if you place radars at different viewing angles away from the tornado, they will see the winds in the tornado slightly differently, and differently enough that when you pull all of the data together, you can actually triangulate the 3-dimensional wind field within the tornado. Now, in the real world, we're not trying to get 300 meters within the tornado because that would be catastrophic. There's no way we would ever get close enough and then be able to pull ourselves away fast enough to avoid getting directly hit by the tornado. But the idea is exciting because what it will tell us is it will tell us how air is coming into the tornado, how air is swirling upward, and how it's exiting the tornado. It will give us basically an X-ray into the really fine detailed elements of the winds within the tornado. And we really need to know this because, for one, we have really high resolution computer models that are simulating tornadoes, but we don't know if they quite have it right. So we need to have observations to confirm if our models are working properly. And then secondly, if we have this data, we can really dissect the guts of the tornado and really understand what makes them tick. Why are they forming? How are they forming? What makes them intensify in some instances and not in other instances? Why might one tornado last for 40 minutes and be 1.5 miles wide, while another tornado is just occurring for 1.5 minutes and remains relatively small? So these are the kinds of questions that I'm trying to ask with my research. And the big picture questions that we ultimately want to get at is foremost warning. How can we have a better system in place to warn for these tornadoes and ultimately save lives and properties? When we put together the various different pieces of the tornado's wind field that we're looking at with this radar data, we are able to gain insights into the formation process and eventually, hopefully, be able to predict tornado onset better and more accurately. Right now, we don't really understand why one storm produces a tornado and another storm doesn't. So these are the types of questions that, when answered, will help us better inform the public and be able to issue better, more timely, and more accurate warnings.